All right, guys, one more rational function. First thing we do with these things is we factor everything completely. So this function right here, I'm looking for two numbers that multiply to -6 but add to +1, and that's x plus 3 and x minus 2. And then for the bottom, I'm looking for two numbers that multiply to +12 and add to -7. And that is x plus 3 and x plus 4, like that. So the question is, do we have common factors? Answer is yes, right here, x plus 3. I'm going to cross those out and I'm going to write my simplified function now. Which is y equals x minus 2 over x plus 4. That's my simplified function right there. Because I crossed out a common factor, this does have a hole. And so I find that hole by setting the common factor equal to 0. The thing I crossed out, I'm setting it equal to 0. And I get x equals -3. Remember, a hole is a point, and so we have to find the y value there. We do that by plugging your x value into your original function, your simplified function, and solving for y. So y equals -3 minus 2 over -3 plus 4. That is -5 over 1, which is just -5. So our hole is at -3, -5. Nice, pretty numbers. That's easy to graph. After we find our hole, we want to find our vertical asymptote. And we find that by setting the bottom equal to 0. When we do that, we get x equals -4. Horizontal asymptote, you find by comparing the degree of the top to the degree of the bottom. The degree of the top in this case, there's just one x, is 1. And the degree of the bottom is again 1. So it's y equals 1 over 1, which is just y equals 1. Your x-intercept here, guys, we find that by setting the top equal to 0. When we do that, we get x equals 2. Remember that that's a point, so it's the point 2, 0. And then the y-intercept we find by plugging in zeros for all of your x's. So 0 minus 2 over 0 plus 4, which is -2 over 4, and that's -1/2. And so that's the point 0, -1/2. That's our y-intercept there. And now that we have all of these pieces, what we're going to do is we're going to graph them. And so I've got the point -3, -5 right here. I'm going to draw a nice big hole there just so that it's easy to see. Okay. I have a vertical asymptote at x equals -4, so that's right here. And I have a horizontal asymptote at y equals 1. I have an x-intercept at 2 and a y-intercept at -1/2, so right here. And so this curve comes up, goes through that hole, and goes through those intercepts there. And my guess is that the second curve is here, but it's always good to check. So we can check using our calculator. And so I'm looking at this graph, and there's my top left curve, and here's the bottom curve that I've already graphed. Okay. So let's go ahead and graph that curve in the top left. And let's identify domain and range. And I'm going to write my domain and range vertically again, just so that you guys can see the parenthesis sets easily. But you can write them all out next to each other if you have room. So remember, domain and range stop for asymptotes and holes. So my domain starts at -∞. And when I'm coming left to right, the first thing I encounter is that asymptote at -4. Start again at -4, and I go to the hole, which is at -3. And then there's nothing else in my way, straight across, -3 to infinity. That's my domain. And again, I would write that out sideways, but I wanted to make sure you guys could see it all. Okay. Range, again, stops for holes and asymptotes. And so here my range starts at negative infinity, and we're coming up the bottom to top of this graph. The first thing I encounter is that hole at y equals -5. Start again at -5, and the next thing we encounter is that horizontal asymptote at 1, and then 1 to infinity. There's nothing else up there. So that's our range. Domain, range. All right, kids, the next couple of problems are things you have not seen before, but if you have a good foundation in graphing these rational functions, you should be able to do this. And it's super simple, I promise. So what they've done is they've given you a graph, and they want us to identify the attributes on this graph. So they're asking us for the vertical asymptote. Well, we know what the vertical asymptote looks like. It's that vertical line, and this vertical line is at 2. So our vertical asymptote is x equals 2. And then they want to know what's the horizontal asymptote. Well, here it is right here. And that y value is 1. And so our horizontal asymptote is y equals 1. X-intercept, this looks like the x-intercept to me right there, is at -5, 0. Y-intercept, looks like it's right here. I'm going to say that's at 0, -2.5. The domain of this function is, remember, domain stops for vertical asymptotes and holes. I don't have any holes. -infinity to 2, and 2 to infinity. And the range stops for horizontal asymptotes and holes. There are no holes. -infinity to 1, and 1 to infinity. And then the last thing is the possible equation. Well, because my horizontal asymptote is not 0, I know that I had the same degree on the top and bottom of this function. I also know I had the same coefficient. I know because my horizontal asymptote is y equals 1, this one was y equals 1, my function looks something like this: x plus something over x minus something, or x minus something over x plus something, sort of like this, okay? And the question is, what were the things? Well, the vertical asymptote comes from your bottom, right? And so if my vertical asymptote is x equals 2, that means I started with x minus 2 to get it, right? Because x minus 2 equals 0 gives you x equals 2. So I started with x minus 2, so that's the bottom of this function. X-intercept comes from the top. And if I had an x-intercept at -5, well, that's x plus 5. Because x plus 5 equals 0 is what gives me that -5, right? X equals -5, and move it back over, this is what you get. X plus 5 equals 0. And so that gives you the bottom and the top of your equation. So I'm going to write it over here just because I've got more space. This is y equals x plus 5 over x minus 2. And this function, because these x's have the same degree and the same leading coefficient, they're going to give you a horizontal asymptote at 1. And it will also give you your y-intercept. If you plug in zeros for x's, it'll give you your y-intercept at -5/2 or -2.5. And so when we have this, what you can do is you can graph this function and see if it lines up with this right here. But your bottom comes from your vertical asymptote, and your top comes from your x-intercept. And then you just make sure that it fits the other attributes of your function. All right, we've got one more where they gave us some attributes and asked us to write a function. So if you read this, it says the equation of a rational function with a vertical asymptote at x equals 3. Well, that's our bottom, right? And x equals -6. Okay, so that's also our bottom. A horizontal asymptote at y equals 1. And x-intercepts at 6 and -1. This is our top and our top. Because this is y equals 1, that means I have to have the same degree. The same degree. Okay, well, if x equals 3, so here's my bottom, right? if x equals 3, move that 3 over. That means x minus 3 equals 0. And if x equals negative 6, move that negative 6 over. X plus 6 equals 0. That's your bottom. X minus 3, x plus 6. That is the denominator of this function. Your top is going to be x equals 6. Move that over. X minus 6 equals 0, right? And I got that from right there. And then x equals negative 1. Move that negative 1 over. You get x plus 1 equals 0. And so your top is x minus 6, x plus 1. And the thing you want to make sure is once you've come up with those, do they fit this horizontal asymptote? The horizontal asymptote at y equals 1 says same degree. Well, look, I've got 2 factors here, and I've got 2 factors here. That means they have the same degree. Okay, and then we also have to have the same coefficient. Well, these are all just plain x's, so they're all going to have the same coefficient. And so the way this would look is y equals, and I would just leave it factored, x minus 3. Oh, y'all, that's the bottom. I'm about to start miswriting here. We'll start here. Y equals x minus 6 over x plus 1, and then x minus 3 times x plus 6. This is your function. This is your function. And that's as far as you have to get. And again, the bottom comes from your vertical asymptotes, and the top comes from your x-intercepts. And then you just have to make sure that what you come up with will actually have the horizontal asymptote that they're looking for. So again, I have 2 factors on top and bottom. That means that I'm going to make a ratio of coefficients. And then all of these are just plain x's, so that's going to give me y equals 1. This graph here, guys, is here in case you want to graph these things to help you out with the writing a function. But honestly, I just take this x equals 3 and move the 3 so you get that factor, x equals negative 6, move it and get that factor. I think this is probably the easiest way to do it. All right, kiddos, make sure that you study the steps to graphing rational functions. Make sure you know those steps well, and just make sure that when you're doing this, you follow the math. Follow the math.